This is section 1. Today we're going to start off by talking about writing equations in the slope-intercept form. So remember, slope-intercept form is this y equals mx plus b, where m is the slope of the line or the constant rate of change, and b is the y-intercept. In other words, it's where it passes through the y-axis on the graph. And remember, that's going to happen when x is equal to 0. Alright, this slope formula here, we've talked about it several times in other videos and in class, and we said the slope can be found by taking y2 minus y1 and dividing it by x2 minus x1. Excuse me. So another way we've talked about this is rise over run, and then we also looked at it as this triangle y over triangle x, and that triangle represents the change in the y-coordinate divided by the change in the x-coordinate. All right, let's jump into a few examples here. We want to write an equation of each line with the given slope and y-intercept. So we want to write this in slope-intercept form. In other words, we want it to fit into this y equals mx plus b format. So y is by itself on one side of the equal sign. We've got the slope of the line and the y-intercept. Well, in this first example, they give us what the slope is, they give us what the y-intercept is. So we're just going to simply plug those numbers in for their corresponding variables, and we get y equals 1/4 x minus 5. And our next one, we're also given the slope and the y-intercept. So substituting those two values in, we get y equals 0x minus 2. Now, when our line has a slope of 0, this 0 times our x variable is actually just going to cancel out, and we're left with y equals -2. And if we remember, we said that y equals -2 is the form of a horizontal line. So you know that the horizontal line has no slope, or I should say 0 slope. Alright, in letter C, it's a little bit of a tricky one here. Now we're given the graph of a line. It passes through 2 points. So we're going to need to use those 2 points to find our slope. We'll say y1 minus y2, which is our -3, divided by x1 minus x2, which is 0. So 3 minus a -3 is going to give me 3 plus 3, which is 6 over 4. Now this reduces to 3/2. So there's our slope. What about our y-intercept? So graphically, we can take a look here, and we can see where it's crossing the y-axis. Right here where x is 0, y is -3. So the value of my y-intercept is -3. Now I can write my equation, y equals 3/2 x minus 3. In example 2, we're given the task of writing the equation of a line that passes through a pair of points. Now we're going to have to do a little bit of digging to find out what our slope and our y-intercept are. So let's start off by finding our slope. We'll say y2, 9, minus our y1, -6. Divide that by 3 minus 0. So 9 plus 6 is going to give me 15. Then 15 over 3 reduces down to 5. So I have a slope of this line of 5. Now my y-intercept, remember, is when x is 0. And if I'm real careful and examine my point, I see that I know when x is 0, my y is -6. So I know my y-intercept here is -6. So the equation of my line will follow as y equals 5x minus 6. And there is the equation of the line that passes through these 2 points, 3, 9, and 0, -6. All right, in our next one here, we're going to need to do the same thing. What passes through this point, 0, -5.8. and 8, -5.8. So we'll calculate our slope as y1, -5.8, minus a -5.8. Divide that by 0 minus 8. So -5.8 minus a negative is plus a positive. Now I have a positive and a -5.8. That will add to 0, and I'll have 0 over -8. Well, 0 divided by any number is just 0. So I have a slope of 0. Now taking a look at my y-intercept, remember, again, my y-intercept will pass through that point where x is 0. So my y-intercept is -5.8. All right, to write the equation of my line, I will write it as y equals 0x minus 5.8. Now again, I have a slope of 0. So that really eliminates this term here, and I just get the equation y equals negative 5.8, which totally makes sense. This is a horizontal line, and it passes through every point where y is negative 5.8. You can confirm that by looking back at your 2 points. Isn't our y value both negative 5.8 for those 2 coordinates? And it is. So here is the equation of my horizontal line, y equals negative 5.8. All right, in 2c, we're going to do the same thing. I'll start off by finding our slope. We're going to say 5 minus a negative 5. Divide that by negative 2 minus 3. So 5 minus a negative is going to give me positive 10 over negative 5. So I have a slope of negative 2. Next, we're going to find our y-intercept. But this is tricky. We're not actually given what our y-intercept is. That's okay. We can actually use one of these 2 points to find out what our y-intercept is. And the way we're going to do that is we're going to substitute that coordinate, one of those 2 coordinates, into y equals mx plus b, and we're going to solve for b. All right, we just found out what m was. M is negative 2. And let's use this second coordinate here, 3, negative 5. The x value is 3, and the y value is negative 5. So we're going to substitute negative 5 in for y. Here's my m value of negative 2, and now here's my x value, and then I have plus b. So this becomes negative 5 is equal to negative 2 times 3, which is negative 6 plus b. Now we're going to add our negative 6 to the left side, and I'm going to have a negative 5 plus 6, and that's going to give me a b value equal to positive 1. So we have a b value of positive 1, which is my y-intercept, and I have a slope of negative 2. The equation of my line is y equals negative 2x plus 1. All right, in our next example for today, we have a linear function based on these given values. We want to write a linear function, based on these values. So our function g, and it has the values g of 3 is equal to 8. Well, this is just function notation, and it's another way of kind of saying that the point 3, 8 is on the graph. Likewise, g of 0 is negative 4. That means the point 0, negative 4 is on the graph. Remember, the number inside the parentheses is the x value, and the number that it's set equal to is the y value. So you're going to do exactly the same thing here for example 3a that we just did up above. Let's start by finding our slope. 8 minus a negative 4 divided by 3 minus 0. Here's our change in our y coordinate is 12. Over the change in our x coordinate is 3, and therefore my slope is 4. All right, now looking at my 2 points, I see that I do know what my y value is when x is equal to 0. So this point here is 0, negative 4 must be my y-intercept. And because it's my y-intercept, I'm ready to write my equation. Y equals 4x minus 4. I got my slope of 4 and my y-intercept of negative 4. And therefore my equation, y equals 4x minus 4. All right, flipping the page over and doing one more little word example here for today. Example number 4 says renewable energy sources in the U.S. generate 143 million megawatt hours of electricity in 2009. This quantity increased at approximately a constant rate. Think of that as a linear slope, all right, or a constant rate of change or slope, and reached 333 million megawatt hours by 2017. We want to write a linear equation that represents the number of megawatts generated by the U.S. X years after 2009. All right, so a few things as we read through this word problem. We want to try to pick out a few points that we can find the slope between, because we saw here that it increases at approximately a constant rate. So 2009 is going to be our year 0, and it had 143.4 2.4 million megawatts, okay? And then in 2017, now 2017, that's going to be 8 years later. Our X value now will be 8. It produced 333 million megawatt hours. So here are our two ordered pairs, our two relations that we can now find the slope between, and then find the y-intercept for, which we actually have right here, and then write the equation of that line. So let's go ahead and find our slope. We're going to take 333 and subtract our 143.3, and then divide that by 8 minus 0. All right, that gives us 189, oops, sorry about that, 189.6 divided by 8 for a slope of 23.7 million megawatts per year. All right, next up, we're going to take our y-intercept, which we actually already know. Our y-intercept occurs when x is 0, and that's 143.4 million megawatts hours of electricity. And let's write our equation. Y is equal to 23.7 x plus 143.4. And what this means is that each year after 2009, it increased by about 23.7 million megawatt hours of electricity each year. All right, in part B, we're going to estimate the amount of electricity generated from these sources in 2021. So what we need to figure out is what x value we need to put in to our equation. And remember, our 2009 was our x value of 0. So we're going to subtract 2021 minus 2009, and that's going to give us a value of 12. So we want to evaluate our equation above for an x value of 12. All right, we're going to punch that into our calculator, let our calculator do that work, and we're going to get approximately 427.8 million megawatt hours. Don't forget your units. It's very important especially when you're doing math. All right, in example 5, it's very similar to the example up above that we just did in number 4. So I want you to pause the video and try example 5 on your own. We'll talk about it more in class tomorrow.